Okay, we're going to take a look at a couple of polynomials in which we're asked to find all the zeros. So it's kind of what we've been working towards as we've gone through this work with polynomials. So we start with the degree 4 polynomial, which means we're going to look for 4 zeros, counting multiplicities. Okay. We are fortunate here that we're given a 0 to start with, one of the imaginary zeros. Okay. And from that, we'll just need to find 3 more. Okay. So keep in mind the first thing we know, since this is a polynomial with real coefficients, if 1 minus I is a 0, its complex conjugate is also a 0. So we sort of get this extra 0 for free. So 1 plus I is a 0. Okay, so we already have 2. Degree 4 means we're only looking for 2 more. Okay. So again, we have these zeros, so we're going to factor them out. We'll factor out this first one. We'll get down to a degree 3. We'll factor out the next one. We'd be down to a degree 2. Once we're down to a degree 2, we have a few more things we could try. Hopefully it will factor. If not, we can always find the zeros using the quadratic formula. So we're going to use synthetic division twice here. It gets a little bit messier with imaginary numbers, but again, our advantage is we know these are zeros. So if we work carefully through the synthetic division, the remainder should be 0. So the first one we have is 1 minus I. I will give you a hint. You want to move these apart a little bit more. Leave yourself a little bit of space. So 1, negative 7, 18, negative 22, and 12. So again, bring the first one down, multiply. And again, notice 1 minus I times 1 is just be 1 minus I. You'll notice I kind of lined up the real parts here. Make it a little bit easier to add. So negative 7, 1 is negative 6. And still the minus I. Okay. This next multiplication gets a little bit messy. So we have to do 1 minus I times negative 6 minus I. Okay, so I'm going to work that out up here. 1 minus I, negative 6 minus I. It's just a FOIL. Okay, so first is negative 6, outer is minus I, inner is plus 6I, and the last is plus I squared. Okay. So that's negative 6 plus 5I for my inner and outer term. Remember, I squared is negative 1. So I'm at negative 7 plus 5I. Add. That's our 11 plus 5I. So we're going to do this again. So again, I have 1 minus I times 11 plus 5I. So again, we FOIL. First is 11. Outer is a positive 5I. Inner is a minus 11I. And last is minus 5I squared. So that's 11. I have minus 6I when I combine my I terms. Remember, I squared is negative 1, so this becomes plus 5. So that's 16 minus 6I. Add. Negative 6 minus 6I. Okay. So one more messy multiplication, and keep in mind this should be negative 12 because we were given that this was a 0, so this should be remainder 0. Okay, but we'll check. I'll put this one down here. So 1 minus I, negative 6 minus 6I. First, outer, inner. And I see that will add up to be 0. And last, so that's positive 6I squared. So negative 6I plus 6I is 0. Remember, I squared is negative 1, so that's negative 6, which is in fact negative 12. And we get a remainder of 0. Okay, so we factor out the first one. It's kind of messy. The second one won't be quite as bad. Now remember, this would be the coefficients for the degree 3. I'm not going to write it all out because right away I'm going to take out the next 0, which is 1 plus I. So I'm going to do it from the remaining polynomial. So I have 1, negative 6 minus I, 11 plus 5I, and negative 6 minus 6I. Again, we know this is a 0, so it should work out that this is remainder 0. So bring this down. So that's 1 plus I. Nicely, again, the i's drop out here. So this just is negative 5. Multiply. So 1 times negative 5 is a negative 5 minus 5I. Again, the i's drop to be 0. So I just get 6. Multiply. I get 6 plus 6I, which in fact does add to be 0. Okay. So I factored out 2. So now I'm down to a degree 2. Okay. So let's come back here and right where we're at this point. So my P of x, I factored out to the two zeros, so I factored out x minus the first one, 1 minus I. I factored out the next one, x minus 1 plus I. And now I'm left with this, x squared minus 5x plus 6. Okay. Again, because we got it down to a degree 2, if this factors, great. If not, we'll use the quadratic formula, but I believe this one factors. So again, each zero, remember, was x minus the 0. So x minus 1 minus I, x minus 1 plus I, and this is, in fact, x minus 3, x minus 2. And now I can see all my zeros, including the first two. So I have the 1 minus I have the 1 plus I. From x minus 3, I get a 3, and from x minus 2, I get 2. Degree 4, I found 4 zeros. 2 are real, 2 are imaginary. Okay. All right, and then one more, similarly. Again, a degree 4, and again, we're given a 0 to start with. Okay, so we'll factor this out. Keep in mind, because these are all real coefficients, I get the complex conjugate for free to be also a 0. So I'll factor out the first one, that'll bring me down to degree 3. Factor out the next one will bring me down to degree 2, just like the last one. Okay. So again, I'll set up my synthetic. I won't need quite as much room because it's just a negative 5i here. And again, keep in mind you're told this is a 0, so it should work out to have remainder 0. So I have 2, so that's negative 10i. Add negative 2 minus 10i, multiply. Now again, we're going to be a little bit careful here. I'll write it up. It's not quite a FOIL, but it's negative 5i times negative 2 minus 10i. So I get positive 10i and the positive 50i squared, which is 10i, remember, minus 50. So I'm going to write the real part first. So negative 50 plus 10i, add, I get 5 plus 10i. Multiply again, it's just a distribution, but you just have to be a little bit careful about it. So again, it's negative 5i times the 5 plus 10i. So it's negative 25i minus 50i squared. So that's plus 50. So I write the real part 50 minus the 25i. Those go to 0. So I just have negative 25i. Multiply these, negative 5i times negative 25i. Remember, that's positive 125i squared, which is negative 125. And in fact, I did get 0. All right. So again, I started with my degree 4. This is now the remaining degree 3. And I'll factor out the 5i, which is my next 0. So 5i times 2 is 10i. That piece goes to 0. That's negative 10i. Imaginaries go to 0. I have 5. And then I get 25i, and that goes to 0. Okay, so again, now I'm down to my degree 2. Okay. So my P of x, I took out negative 5i, so that's an x plus 5i. Take out the 5i, that's x minus 5i, and I'm down to here, 2x squared minus 2x plus 5. And again, I have my 0 from here, I have my 0 from here. There's 2 more zeros buried in here. If it factored, great. I don't think it does. So I'll just use the quadratic formula on it. Okay. So again, just so I don't lose track here, I have my zeros, the first 2. And I'll list the other 2 I get from the quadratic formula. So the opposite of b, plus or minus square root b squared, is 4 minus 4a c, which is 5, all over 2a. So I get 2 plus or minus the square root of 4 minus 40 over 4. That's the square root of negative 36. which is 6i. Okay. I can factor out a 2. It's 1 plus or minus 3i over 4, and then cancel. So I get 1 plus or minus 3i over 2. Okay. So my other two zeros would be 1 plus 3i over 2, and 1 minus 3i over 2. And again, our 4 zeros, in fact, these are all imaginary, which means if you graph this one, the original polynomial, because all your zeros are imaginary, you have no real zeros, which means no x-intercepts. Okay, this is a degree 4, so both ends open up, and the entire graph will stay above the x-axis.